Hello, everyone. Welcome once again to our series on strength of materials. And to this channel, kindly subscribe, like, share, leave your comments and suggestions at the comment section. We are looking at shear and bending moment diagram for beams. Shear and bending moment diagram for beams, example 1. Let us look at our question today and see how we are going to analyze. Good. Draw the shear and bending moment diagram for the beam and loading shown and determine the maximum shear force and bending moment. So we have been given this diagram as we see on our screen, and we have been asked to draw the bending moment diagram, the shear force diagram, and also to determine the maximum shear force and the bending moment. Quickly, let's look at how to analyze this question. Good. So we have been given this question, and just as we saw from our previous lecture, we made mention of the fact that anytime you are given a beam to draw the bending moment and the shear force diagram, the first step you need to do is to draw your free body diagram. To draw the free body diagram of the structure. So let me draw the free body diagram here so that I will draw the shear force and the bending moment diagram under it. It is mostly very good practice to do that. So this is my shear force. So you draw the diagram. As you see, and the free body diagram, we have 10 kilonewtons at this side, 10 kilonewtons. Then there's a support at C. There's a support at C. So this point is A. There's a support at C. So this is a support at C. And we are told that it's a pin support, but the X component will be 0. Therefore, we only have CY because there's no force in the X axis. And the distance from this to that is 1.5. And the distance from this, there's another force applied here, B, which is 25 kilonewtons. And there's another force, 20 kilonewtons applied at this side. So let me extend it at this side here. 20 kilonewtons. And then there is a reaction at B, which is a rocker. So this is B. You can call it BY. And the distance from this to that is 3. The distance from this to that is 8. And the distance from this to that is another 3. So once you have drawn this, what you need to do is to determine the reactions at the support. So for the pin support, you can even bring the S component here and call it CX. But there's no other force in the horizontal. So sum of forces in the X will be equal to 0. Then from here we can see that minus N 10 is coming down, so minus 10. The 25 is also coming down, minus 25, minus 20, plus, because the 10 is coming down, minus 25 is coming down, minus 20 is coming down, minus CY is going out positive. So CY plus DY is also going out positive. It's equal to 0. Then from here we can say that CY plus DY should be equal to 55 kilonewtons. So this is our first equation. Let me write the equation here so that I can be able to draw the bending moment diagram down this one. Let me finish with this side. Then we can say that this is sum of s is equal to 0. So we can say that Cx is equal to 0. But this what you have done here is for f of y. The forces in the y is equal to 0. Then we can say that sum of moment at any point, the reactions, we can say at B or at C should be equal to 0. So at this case, let's take our moment at B and say that sum of moments at B is equal to 0. So from here, we can say that 10 times 15.5 minus CY, the 10 times 1.5, not 15.5. Oh, we are taking moment at B. So this is where we are taking our moment from. Therefore, the distance of this 10 to where we are taking our moment is going to be 1.5 plus 3 plus 8 plus 3, which is going to give us 15.5. But from the diagram, this will be a point of rotation. So once we apply the force here, we expect it to rotate our whole structure in this direction, which is in the anti-clockwise. So it's going to be positive. Then CY, the force here. Now, if you apply the force here, and this is the perpendicular distance, then it's going to rotate it in this direction, which is going to be clockwise. So it's going to be minus CY times 14 plus 25. This force, which is 25. So this is where it is applied. The perpendicular distance where we are taking the moment is going to be 8 plus 3, which will be 11. We have plus 25 times 11 plus the 24th. Also, this is a perpendicular distance. It's 3, and from the direction, it's going to rotate in the anti-clockwise direction, which is going to be positive also. So we have 20 times 3 is equal to 0. And from here, we can be able to find CY. 14 CY should be equal to 490 kilonewtons. And from there, we can say that CY should be equal to 35 kilonewtons. Once we are done determining CY, we can put the value of CY in this first equation here. Then we can get BY. So from there, we can say that CY plus BY to be equal to 55. And from there, BY will be equal to 20 kilonewtons. Just put the value of CY here and you bring it to that side. So 55 minus 35. Once we are done determining the reactions at the support, the next thing we need to do is to get the internal force for each of the individual sections. So what we are going to do is to divide our beam into sections. Where are we going to divide it? We are going to divide it at the point of discontinuity. And what is the point of discontinuity? Discontinuity happens anytime we encounter a new force. And we stated that always you start from the, let me still re-echo that you start at the left end. You start at the left end. And this is your longitudinal axis, it is in the x-axis. So this will be our origin, which is a 0 mark. Therefore, you always start from the 0. As you are moving from this point, you encounter a reaction at this support. So that is going to be one session. We are going to get one session like that. As we move from that, you encounter another force. So this is going to be another session. As we move from this point to that point, you encounter another force, which will be another session, and of course the last session. So from here we can have 4 sessions. You have session 1, session 2, session 3, session 4. So we get the internal force and the internal shear force and the internal movement in each of the sessions. So first of all, let's pick the first shear force. Our 10 is up here. This is 10. Then the shear force should always be in the positive direction. Indicate the shear force to be in the positive direction. So we can call this V1. And the moment is also in the positive direction always. Make sure you do that. So from here we can say that V1 is pointing downwards. Therefore, negative V1 minus 10. The 10 is also pointing downwards. Is equal to 0. So from there we can say that V1 will be equal to negative 10. Then you can also get the moment, M1. So we take the moment at, so when you pick the session is from point A to point C. The session is from point A to point C. Therefore, you take the moment at where you are cutting into 2 halves. So this is where we are taking the moment at point C here. Is where we're taking our moment. So we already have the M1 there. So sum of moments will be equal to 0. From there we can say that sum of forces in the Y will be equal to 0. So our moment, we have M1 there already, M1. Then we have our 10 multiplied by the perpendicular distance from this point to that point. We are told that it is 1.5. But look at it, it's going to rotate the object in the anti-clockwise direction. So if I have my structure like this, if I have the structure like this and I apply a force here, and this is the point of rotation, then it's going to rotate in this direction, which is anti-clockwise. We are going to get M1 times M1 plus, no time, sorry for that, M1 plus this 10, which we are saying times the perpendicular distance to get the moment. So times the perpendicular distance from A to C is 1.5 to be equal to 0. And when you do the math, you find out that M1 should be equal to negative 15 kilonewtons. Then we go to section 2, C to D. We draw a free body diagram like this. We have a force of 10 applied at A. We have another force applied at C, which is CY, you already know. And since you are considering section D, the force at D will not, section C to D, the force at D will not play a role. So this will be where we are taking our moment. Our shear force is always in the positive direction. You can call this V2. And our moment is in the negative, it's also in the positive direction, anti-clockwise, which is M2. So from there, from here, we can be able to get our shear force. We can say that negative V2 coming down and it's negative, CY is going up and CY is 35 kilonewtons. And this 10 is coming down also, so minus 10 should be equal to 0. And from there, V2, when you go through the process, you find out that V2 will be equal to 25 kilonewtons. And from there, we determine the moment in that section. So the moment in that section, we already have our M2. So M2 is in anti-clockwise positive. Then this force times the perpendicular distance where we are taking a moment. This is where we are going to take a moment where we cut into pieces. So the distance from this point to point B is 1.5 plus 3, which will be 4.5. Therefore, we are going to get 10 times 4.5. 10 times 4.5. And is it going to be clockwise or anti-clockwise? We have already established that it's going to be anti-clockwise, positive. And we have our CY, which is moving upwards. So we have our diagram like this. This is C where we are taking a moment, and CY is somewhere here. So this is going to rotate the object in this direction, and this is in the clockwise direction. So minus CY, which we are told that we have calculated, is 25 times the distance from there to where we are taking our moment, which is 3, is equal to 0. And when you do the math from there, M2 will be equal to 60 kilonewtons. Once you are done with that, you go to section 3. You also determine the internal shear force and the internal bending moment. So from there, section 3, this is going to be our free body diagram. So this will be for section 1. Section 1, this will be for section 2. Then this will be for section 3. So for section 3, we still have our 10 kilonewton force applied here. We have our CY applied at the distance of CY is 35, applied at the distance of 1.5. And then we have now the force at D, place a rho at D. So the force at D is here. This is the force at D, and that one is 25 kilonewtons. And this is where we are taking our moment. So as usual, our shear force will be moving downwards. You can call it 23. And our bending moment will also be acting that direction, which we can call as M. Allow me to clean this session so that we can get space for our analysis. So from there, we can say that V3 pointing downwards negative, so negative V3 minus 10 pointing downwards also, minus 25 pointing downwards plus 35 pointing upwards, so it's positive is equal to 0. And from there, V3 will be equal to 0 kilonewtons. Let's find the moment M3. This is M3. So we can say that M3, we are taking the moment at point E. So M3, and then we determine the moment. So all the forces times the perpendicular distance, 10 times the distance to where we are taking the moment, E. So it's 8, the perpendicular distance is 8 plus 3 plus 5, which will give us 12.5. So we have 10 times 12.5, but it is going to be clockwise. It's going to rotate the object in that direction, the clockwise direction. So positive minus, now we have the CY, which is also 35. It is going to rotate in the clockwise in that direction. So minus 35 times the distance to where we are taking the moment from CY is 8 plus 3, which is 11. Then we have the 25 kilonewtons. The 25 kilonewtons is going to also rotate in the, so this is a 25, and this is where we are taking the moment, and this is a perpendicular distance. So it's going to rotate also in the anti-clockwise direction to give us plus 25 times 8 should be equal to 0. And from there we can say that M3, when you simplify, M3 should be equal to 60 kilonewtons. Then now we are left with the last section, which is at from E to B. So we can get section at point B. And therefore, when we section at point B, we are going to get our structure like this. We have a force of 10 applied at the end here. So this is 10. This is 10 kilonewtons. Then we have our CY also at this side, which is 35. We have another force here, which is 25. And now we have encountered another force there, which is also 20. And of course, our shear force will be positive, therefore, and our movement is going to be also in the positive direction, M4. So from there, we can say that V4 coming down, so minus V4, N is coming down, 25 is coming down, 20 is coming down, 35 is going up to be equal to 0. And from that analysis, when you simplify, V4 should be equal to 20, negative 20 kilonewtons. And let's also try to find the one in let us try to find the one in the M4. So M4, the moment M4 is already there, it's in the positive, and it's going to produce an anti-clockwise motion. So we have plus N times the distance from this to where we are taking the moment, 1.5 times plus 3 plus 8 plus 3 will give us 15.5. Minus 35 is going to produce anti-clockwise rotation. So 35 times the distance from the 35 to where we are taking our moment, point B. And that is 3 plus 8 plus 3, which will give us 14. Minus 25 times the distance to where we are taking the moment, this 25. So the distance will be 8 plus 3, which is 11. And because that 25 is going to produce an anti-clockwise motion, so it should be plus 25 times 11. Then we go to the last force, the 20 will also produce anti-clockwise rotation, looking at its orientation. If we are taking the moment here and the force is applied up here like that, it's applied up here. Then it's going to rotate it in this direction, which is anti-clockwise. So plus 20 times 3, the distance where we are taking the moment is equal to 0. And from there, the moment, when you do the math, the moment M4 should be equal to 0. And once you have been able to get all our shear force and all the bending moment in all the individual parts, we can now draw our shear force and bending moment diagram. it is always advisable to draw your shear force / bending moment diagram under the free body diagram. Here I have cleaned my free body diagram. So for that matter, I am going to draw my shear force and bending moment diagram under the structure. So don't forget that this was the session we divided our thing into. We have the first section like this. I'll trace it downwards. This will be the second section. This will be the third section. This will be the fourth. And this is going to be our last section, of course. So for the shear force, we just draw our vertical representing the shear force, and we draw our x-axis representing the length, up to the length of the structure. And then we see from the diagram that at the first point C, the distance between A and C, the shear force there was -10. So we represent our -10. Negative always come down of the y of the x-axis, and positive goes up of the x-axis. So we have -10, -10. Let's place it somewhere here. -10. So -10 on the first axis, it was -10. So indicate that mark. On the second one, the shear force was now 25. So 25, you can indicate it somewhere here at 25 on the positive side. Sorry, it shouldn't be indicated. It should be indicated on the next line. So our 25 will be here on the second session. And in the third session, our shear force was 0. And in the last session, our shear force was -20. So -20 we can represent here on this as -20. And we indicate it here. So what we do, we just start from, we draw a straight line from the axis up to this point, because that is the starting shear force. This force here will produce 10. So that 10 is going to be the starting shear force. So the shear force up to this point. And once you reach this point, there's a discontinuity. So you move upwards to this point. Once you reach this point here, there's another discontinuity. So you come down, and then you draw your line to your 0 discontinuity on the graph. And once you have drawn the 0 continuity, you could easily see that there is a discontinuity. So from here you come down, until now you reach the 20, which is for the last session. 20, which is for the last session. And we just bring it to the x-axis because there's no length again. So we assume that now the shear force is 0. Once you have been able to do that, you go to the bending moment diagram. Also, we indicate the bending moment. And let me change my color a bit. So this will be my moment axis. So this will be going to be moment. And I draw my x-axis like this up to this point. And the moment, the first moment, always take note of this. The starting moment is going to be 0 at the starting point. There is no bending at the starting ends of the bar. There's no bending at the starting ends or the end part of the bar. So the bending moment at A will be 0. The bending moment at point B will also be 0. So the bending moment diagram always starts with 0, which is at this point. Then we saw that at the second session, the bending moment increased to -15. So we can write our -15 somewhere here. -15. Then, so this is the point on the second session, -15. On the third session, we realize that now, at the second session, the moment changed. And the value of the moment at the second session was 60 kilonewtons. 60 kilonewtons. So we indicate as 60 on our second session. So this is 60 on the y-axis, so 60. And the third axis, we realize that the moment was equal to 60 again. So on this side, there's also 60. And on the last side, the moment goes to 0. The moment goes to 0. So on the last point, the moment goes to 0. Therefore, drawing a diagram, we said that to start from 0 and end at 0. So 0, starting from 0 to this point, we move through to this point. Then it is constant up to this point, and it starts decreasing. It starts decreasing to 0 at this point. So this will be our shear and bending moment diagram. It is very easy, and the point of inflection or the point of contraflexion is this point. Is this point where the graph has the x-axis aside the two endpoints. Good. And we're asked to determine the maximum shear force and the maximum bending moment. So the maximum shear force is 25. So this is corresponding to the highest part of the graph. And the highest bending moment corresponds also to the highest portion of this graph, which is equal to 60. And this brings us to the end of this question. I hope we all understood the concept, and it is quite a bit easy. Don't be afraid of it. Just tell yourself you can, and it is very easy. Very easy. It is very, very, very easy. But if you don't understand, also don't hesitate to make us know your concerns and your comments. So once again, we want to thank you so much for staying in touch and keeping with us up to this point. We'll end here until then, until we meet again. Bye-bye.